I've got my hat on today as an architect. I am a senior architect at the Concrete Centre, and if you're not, and what I'm going to be talking about today is cutting carbon using concrete. I don't know if you know who we are as a Concrete Centre. I've been there for 10 years now. Before that, I was the director of practice in South East London. And we produce lots of free publications and guidance about how to use concrete, get the most out of it, and lots of... I'm going to actually, all the way through this talk, what I'm going to do, I've got far too many slides. If anybody's ever heard me speak before, I always have far too many slides. But what I've got is a little logo in the corner, a link to a publication of where you can find out more information. And I'm very happy for people to have the presentation afterwards, just ask me. Or actually, I think there's also, if you can tweet in if you're interested, these slides will be sent to you. So, all the information about the Concrete Centre is on theconcretecentre.com. There's also another website, sustainableconcrete.co.uk. Now, I'm talking about carbon in this talk, but actually, as I'm sure you're all aware, with regard to sustainability, it's a much more complex issue. And as we all know today, boiling any important question down to a yes, no, in, out, remain, don't, good, bad, is not a good idea. And sustainability, like life, like construction, like architecture, is complicated. It's the reason why there are multiple goals from the UN sustainability goals. It's the reason why there are 9 categories in BREEAM. You know, there's lots of things one needs to think about. And there's not one single issue, and actually it's a lot of changing emphasis and changing measurements with regards to sustainability. And concrete actually can meet lots of this. Lots of very good sustainability inherent qualities of concrete. Maybe some of them you wouldn't be really thinking about. Fire actually is, but there's flood resilience, durability. I'm not going to be talking about any of this. Vermin, VOT resistance. Actually, a lot of people are not really aware of this. The concrete doesn't off-gas. So, you know, there's really good contributor to good indoor air quality because there's no VOCs or formaldehyde or hidden glues or anything in that material there. But it's also local, you know, concrete. If you're using concrete in the UK, now I mean, some people are saying, what's concrete doing as a sustainability presentation? It's absolutely has got its place here. Many people don't realise they hear global figures. If you're using concrete in the UK, concrete will have been made and sourced from the UK. And that's a really important factor to understand because the UK concrete industry is leading the way in many aspects with regards to sustainability. And I'll talk a little bit about how I know that. And it's not a coincidence that I joined there 10 years ago. And there's a 10th anniversary of its sustainability strategy this year. So it's local. There's actually everything you need for concrete is here. Also, being local, it means that we can trace it. It's traceable, ethically sourced. It's already covered by all the European standards. So practically all concrete is certified to the highest responsible sourcing standard, the BS 6001. Part of a circular economy, you know, concrete's got recycled content in it. You can design it to have that. It can be designed, it can be reused, designed for long life. Lots of fundamental principles of the way that you use concrete can fit into a circular economy. And the more we think about this, and we've all got to be thinking much more about this going forward. Actually, from a circular economy point of view, you might not be aware that concrete industry in the UK uses over 200 times more waste than it produces, which we didn't believe when we first started measuring this stuff. But a lot of that is to do with the waste that's used to burn to make the cement in the process. And so it's using waste as an alternative fuel. So very important in the sort of symbiosis of different industries and the way that they go together. And the reason why I know about this is because, as I said, the industry has just finished celebrating its 10th year anniversary of measuring stuff. So we're talking about the roadmap to zero carbon, hugely important thing. We've all got to be doing step change, making decisions as architects, making the right decisions, thinking harder about the decisions we make within our buildings. The industry have been doing this for 10 years and reporting on it. And it's a cement. I'm going to talk about cement later on, but cement had a 2080 strategy 20 years ago, something like that, not really sure. Anyway, it's now being revised to get to zero carbon. It's planned to get to 80, until this year, it was an 80% reduction. It's now looking very hard at how it can get to that final 100% by 2050. So lots going on, lots of measurements. So if you're interested in this, there's all the different data and measures are reported and measured every year and put online. But I'm going to talk about carbon, because obviously carbon was one of the measures there. Now, this is a very oversimplistic diagram, and in fact, I've missed out. I'm talking about whole life. We're talking about embodied carbon and operational CO2. The two need to be added together, as well as what happens at the end of the life of a building. All of these things need to be thought about. Now, one of the things that's very commonly misunderstood, until very recently, until actually just the UK GBC brought out their new definition, until then, every single guidance that I've come across, as far as I'm aware of, that talks about carbon, like zero carbon homes, was all to deal with operational CO2. So we're talking about the carbon associated with the energy use of a building. And it still remains one of the most important things and the overarching thing that we need to focus on. But one needs to think about the whole life carbon of a building. So we need to think about embodied CO2. I said this is oversimplistic. How that pie is sliced up completely depends on how long the building's going to live, what type of building it is. It's going to change as the profile of our energy use and our energy profiles decarbonized grid. But it's just as a way of, we're all visual animals, aren't we? We're architects, just sort of factor these things into our brain. So that's the reason why my number one point, and I've got just 4 of them, of ways to cut carbon using concrete now is to use the material to help reduce the energy use in a building. Now, you can do that with all materials. Concrete can also get there as well. Obviously, we're all familiar with this, I'm sure, Part 1L, 1B, PHBP for Passive House. We heard a great talk earlier on about this. It's recognizing that the way that we build our buildings, the decisions that we make about the fabric of the building is hugely important to reduce the amount of energy. And that's not relying on sort of eco-bling of plug-on PVs and things like that. We need to actually just get the fabric of our buildings right, which is a lot about Passive House principles there. But so U values, so insulation, reducing thermal bridges, air permeability, and thermal mass as well, all recognised as being part of the role. And there are lots of very good, well understood and proven buildings that have got good energy efficiency and high performance in that regard, using concrete and I've said in using concrete products, don't forget blockwork is a form of concrete. So it can get there. Now, if you want guidance on how to get there, I'm not going to go through all of those details in terms of detailing, but there's lots of really good publications that we've been producing over the years, and you can get them all free and download them from the website. There were some that we produced with zero carbon homes a few years ago. But I also wanted to alert you to this one if you don't know about it. This is the block industry have produced a series of free details. This is tackling thermal bridging in particular. And you can download these details, and they have already within them pre-calculated psi values. So that's what you need to be able to put into your SAP calcs to be able to to recognise that you've actually done an improved detail, that you're not going to have such low thermal bridging in the building. If you don't, then you're going to be penalised for an overall figure in the calculation of SAP. That's if you'll all be using SAP. They don't specifically get used for PHBP, for Passive House, but they're really good basic principles of design that we should all be looking at. So if you don't know about them, websites there for the different types of block work. So the other one that I was worth talking about, a little bit more detail, because this is the thing that is unique to concrete in terms of using it as a structure, is the thermal mass. Are you all familiar with how thermal mass works? I hope so. This isn't a new concept, but it's just a reminder that you can use, if you've got I love this building, but for its use, the thermal mass we'd be getting would be from the floor, so it is why this is feeling cool on a day like today. It's got when you're building within a building, it's a very good way, within an environment like the UK, it's a way of being able to even out the temperatures. And the way that can help us save energy, is in the winter, it can help reduce the amount of heating that one would need if you've managed to capture some of the solar gain in the fabric of the building. So the fabric's there already. It's just saying, right, we're going to absorb some of that sun coming in during the winter, which means that there may be slightly, during the night, I can put my radiator on just slightly later in the day, say, or it doesn't need to be quite so much higher. So you can getting all that free energy from the fabric energy store back into the building during the winter. It's also got its value in the summer, and increasingly going to get its value in the summer for passive cooling. So the way that works is you need the concrete or you need the thermal mass. There could be brickwork on the inside, though we don't tend to build these days with brickwork on the inside. But that's thermal masses on the inside of the insulation or within the floor. So you want to have that, you need to be able to see it. That's the key thing, or touch that thermal mass to be able to reap the benefit of it. Now, in other buildings other than homes, the thing that all of these BREEAM outstanding buildings have in common is that they're all concrete frame, and they all use the thermal mass. Some of you might recognise them. They're going to be some of your buildings as well, I'm sure. They all have using thermal mass to be able to keep the building cool. So using the concrete to be able to avoid, or at the very least, reduce the amount of energy of air conditioning that's needed in a building. So it's a well understood strategy of using thermal mass with good ventilation and nighttime ventilation to save energy. And that means either exposing that concrete or painting it. Getting a light time purge, a really important part of the factor of the process. So you're going to be able to get cool air through there, or cool water, to be able to reduce the amount of heat overnight, so that the building starts off cool. And these are the benefits you can get there. So a typical air-conditioned office will be using about 125 to 150 kilograms of carbon dioxide per metre squared per year. But actually, a high thermal mass building can get that way down. So this is the data behind the principles of establishing how you can use concrete to save the carbon use that accumulates through the life of the building. So this isn't about saving right at the beginning. It's actually saying, right, actually what we're going to do, we're saving energy and carbon throughout the whole of the life of that. So the way that you can, as I said, the best way of being able to tap into that is to be able to expose the surfaces. Brings me on to my point number 2, which is material efficiency. So actually, the concrete can often get you there. It can give you your structure, as well as often your fire, maybe even your acoustics, and the building performance, without the needs of lots of other finishes. So actually, it's doing more with less. Another really good sustainability strategy. And that brings me on to the second one. It's about using material efficiency solutions. So using that concrete, but using less of it. Using the concrete to use less other stuff. So thinking just consciously about what we need. You know, we didn't need another floor on here. This structural floor is doing the job it needs to do. We didn't have to put anything else down. And there's a few bits of data about how the amount of material of tons of wastage, and also the amount of carbon that one could save by emitting the ceilings. You know, it's quite a good excuse of not having to put a suspended ceiling in as well, obviously. But it's not just that. So thinking about the fact that we need to make some decisions now, actually avoiding air conditioning saves on all the embodied carbon dioxide associated with the carbon footprint of the air conditioning kit. And then, of course, every 15 years or so, however often that needs to be replaced. So you're saving on embodied CO2 throughout the life of the building. So this is where the sort of relationship between embodied CO2 and whole life carbon starts to come into play. How am I doing for time? Right, not too bad. So that's using concrete to use less other stuff. It's other stuff that often tends to be a little bit less durable, maybe needs to be replaced, or giving opportunities for people to be able to put stuff in and then take it out, but retain the mass of that structure and being robust enough to be able to take the way it can be knocked about. The next one is using the concrete so that you're just using less of it, so really efficiently in design. The basic principles of what most structural engineers are trying to do anyway, but hollow core floors, putting holes where they're not needed for the structure, or ribbed deck. There's a lot more ribbed surfaces or trough ceilings that are coming through. It means you use less concrete, but you've still got your thermal mass. In fact, you've got lots of surface area there, which helps. It makes the concrete slab lighter, means your footings can be smaller, so you've actually got less overall concrete used. And so you're still getting all those benefits of the concrete, but using less of it. Post-tension slabs, absolutely brilliant for high-rise. So over 10 stories compared to a... do you know what post-tensioning does? No, I see. I've got a whole hour just describing what post-tensioning does. So post-tensioning is where you're putting in, rather than a whole mesh of steelwork, you're actually grouping them in a really efficient way of reinforcing, where there's cables that get laid in strands inside these tubes. They get pulled tight, and the concrete's poured, and then it's released. So the whole slab is held in tension. So it's a bit like holding some books. You know how you could hold a whole load of books and not together at one end. I can't speak, and so that I haven't got the microphone to do my post-tensioning dance. Hopefully you get the picture. So it's in tension. It's grouted, so it's not going to go ping when you cut it. What it does is it's a very efficient way of being able to get that floor slab down really slender. In fact, it can become so thin that it might not be enough to meet your acoustic requirements. So you've still got to watch how far you go. But over 10 stories, each one can become so slender, by the time you add it up to 10 stories, compared to a steel frame building, you've saved a whole floor of space. And in fact, I think it was at 240 Blackfriars by HMM. I don't know if anybody's from HMM here, AKT, I think, with the engineers. That got planning with a 17-storey building in steel frame. And they actually, by changing it to a post-tension concrete frame, were able to then go for 19 stories. They said, well, how sustainable is that? Well, they could have actually lowered the floor. And if they'd have lowered it down to that same height, got all that accommodation in, they'd have saved on all the embodied CO2 associated with all the cladding and everything else associated with the building. Now, of course, that isn't what happened. But then if we're looking at land use and density, it was a very efficient use of material in that regard. Or off-site construction. We hear a lot about this as being the sort of holy grail of everything that's going to solve all our problems. Is it? I don't know. It's going to help. But obviously lots of benefits associated with that with fabric production and low waste on site. This is one of my favourite recent buildings. Is by Bennett's Associates, Royal Pathologists. And they went for a ribbed slab there. They reckon they worked out to about a 40% saving in the amount of concrete that they needed. And by being a lighter frame, large spans, they're actually able to reuse the existing slab in the ground. Again, really good principles for sustainability of reuse. And they've saved carbon all the way through that process as well. So that's on to my third point. And in fact, actually, looking at that talk, this is a really beautiful coloured concrete, just much paler and lighter. And that's because they've used GGBS in the mix. It's a low-carbon form of cement. And I'm going to talk about that now. It's actually lowering carbon through specification. Now, we're all empowered to do that as architects. We've just got to ask for it. It requires a little bit of understanding of knowledge, and I'm going to give you a little bit of a concrete manufacturing lesson, if that's all right. But there's lots of different ways in which concrete can be provided. Obviously, it can be off-site, in situ, pre-formed blocks. It can be made to order. If it's a product, you're going to look at the packaging effectively. You're going to talk to the manufacturers and make the selection about what's been provided with you. What you make, between one block and another, what's got the most recycled content, if that's the thing that you're considering, or what's got the low carbon footprint. So that's fairly easy. That's like any other material that becomes prefabricated. You just got to look at it. Look at the environmental product declarations. If you don't know about these are all what's starting to come through, replacing the Green Book, EPDs. If it's ready mix, or if you're specifically requesting some precast to be made for you, it requires you to understand a bit more about the recipe. And I often talk about this. Concrete is just a bit like baking. It's all about the ingredients. And what you're doing is you're saying you want to effectively go for a low-fat cake rather than cakes or bread. Which one am I going to go for? Low-fat bread or brown bread? You're choosing the right ingredients. Okay, designs are there. If there is no one such thing as a concrete mix, there are thousands of different concrete mixes. So actually, this point is choose a low carbon concrete mix. It's almost just as simple as that. Now there are some overlaying other technical issues that structural engineers are going to be needing to be thinking about, but actually just ask for it. We should all be doing that. And the way that we specify it does require a little bit of knowledge. So bear with me. So most of concrete is this stuff, rocks, right? Coarse aggregate. It's also got some fine aggregate, sand. Actually, a lot of it in the UK is crushed rock. It's going to have a bit of water, but cement is the key thing that turns all of that loose stuff into concrete. Cement is the binder. Actually, cement, even though it's only about sort of 10, 12%-ish of the whole mix, it's what brings 75% of the carbon footprint to concrete. So it's all about the cement, what type of cement you're specifying and what you use. There'll be some reinforcement in there. And in fact, if you look at our document, which I did bring with me a whole pile of them, but they've all gone. Some people have got some here. Specifying sustainable concrete there. This comes from there. It tells you, so Portland cement, so it's just under 9,000 per tonne. Don't forget, that's not concrete, that's cement. People get mixed up. We talk about a small amount in large amount of concrete. But then you've got these additional things, additions or cement constitutes, sometimes called cement replacements, GGBS, ground granulated blast furnace slag, fly ash, limestone. These can be mixed and are commonly mixed with ordinary cement to provide, you can see how much lower they are in carbon footprint. These are byproducts of other industries as well. Mix the two together and you are lowering the carbon footprint. And they will do that. They do that in the ready mix plant already. There isn't a ready mix plant in the UK that I know of that doesn't stock one of these as standard. Right? This is stuff that's been going for a long time. We've just got to know to ask for it. Aggregate, so most of our concrete is just really low in carbon footprint is aggregate's really low. It's a naturally occurring material. A bit of recycled stuff in there potentially as well. But reinforcement obviously is high. That's steel. That's what you would imagine. So you're trying to keep that down. That's down to structural engineers. So basically what I'm saying is, in that mix of all those stuff, that amount that was cement, you could just say, right, I just want 50% of that to be GGBS. I want it to be an other type. It has a cementitious properties, this slag, but it's and you wouldn't be able. You can't go to full 100%. There are limitations under the British standards to how much you can replace, but that's the basic principle. Okay, does that make sense to everybody? Yeah, I mean, there's lots of really great buildings around. Many more of them using GGBS. It makes the concrete lighter and paler as well. 50% is a very common mix. Somebody once said to me they thought that was the most common mix in London at the moment, which I thought was quite interested in. Sometimes the contractors might be trying to be saying, no, I want you to go to 30%, because they get a bit worried. It starts to get a bit sticky, a little bit harder to place maybe. I always say sustainability is going to trump that any day, to be honest. It also just takes a little bit longer to get its strength. It still gets the same strength, but it needs to stay, it's what you call early strength gain. It will need to be in the formwork a day or two, depending on what the weather's doing, before you can strike it. So it's important that you get this in your specification early on so that everybody's tendering on the same basis. But what this is saying is, in order to achieve the same performance, so an RC3240, typical performance specification for concrete, you could have all these different types of cements, and they could all have different carbon footprints. So you're just going to, I'm assuming you'd like to just say, I'll go for the lower one. Okay, so that's the key thing. There's loads more about it in this publication, as I said. Lots of guidance, lots of different types of mixes that you can think about. So this brings me on to my last point, is so using the concrete to its best, use the thermal mass, lower the accumulating carbon throughout its whole life, get the carbon footprint of the concrete down and low as well. But then also, every building that you do expends energy. It needs effort, it needs energy, it needs resources. Make it last. Doesn't that principle? We're all used to sort of, we're pretty much a throwaway society, aren't we? I mean, I don't know how many people have ever darned a sock before, but, we used to darn socks. You buy your socks, make them last, and they'd last. It's also the milk bottle strategy is more likely. It's actually designing a building, I was brought up in Germany, and I was totally used to being able to, going back, I'd pay a deposit on whatever bottle I've used. I said growing up, I'm talking about beer, not when I was growing up, obviously, anyway. But those of you who've come aboard, you know that bottles kept as a bottle, reused as a bottle. Why are we crushing them up to make new bottles? That's a much better, from a strategy of applied to buildings, it makes a good principle. Use that structural frame as a building in place. Why are we talking? I mean, obviously, it's got its place with other types of materials, but it's a very well-recognised strategy for circular economy and for reducing carbon, is that we just reuse that frame. There's lots of buildings at the moment, 60s buildings that are being repurposed, stripped back, remove the cladding. The bones of the building were right. What we're doing is we're reusing those bones, and we're extending the life of that usable building by reusing it. It makes a good principle. It's a really good principle for building. Obviously, it does require some thought about span and floor-to-ceiling height and things like that. But from a concrete point of view, it's already there. The concrete that's designed for the inside of a frame of a building for 50 years actually already lasts 100 years. You don't have to do anything different to the specification to get there. And also, you may not be aware that throughout the whole life of concrete, as it's curing, it's constantly absorbing CO2. So that original expenditure of a carbon footprint, actually up to a third of it is sequestered out of the environment throughout its entire life. There's like a spike at the end of life when you expose it and crush it up again. But that's important. It's becoming more recognised as we're going forward, and people are sort of looking at how we need to be carbon accounting much more accurately than we have done in the past. But if you think about the future, we need to be thinking about what the weather is going to be like, what's the climate. Concrete is absolutely geared up for being absolutely appropriate for climate change adaptation, so dealing with flooding, overheating, as I mentioned before, totally recognised as being a means of being able to keep a building cool. So if you make those decisions early, you've built in the tools without needing to do anything different. It's inbuilt passive cooling potential there for the building. And then just really quickly, I know we're getting time I'm being, is that the industry is absolutely, I would not be within the industry if I wasn't happy that they're completely committed to doing carbon. I've just talked about what we're doing today. In the future, concrete could look completely different. And there's lots and lots of work going on into cement. Already there's lots of changes to being able to use more limestone within the mixes. There's loads of research going on into alternative types of cement, not only just using admixtures and lightweight insulating concrete. This is already available now, but starting to look at concrete sequestering. So concrete that doesn't go off by water, it actually goes off by reacting with carbon dioxide. So it completely sequesters the carbon dioxide in that mix. And already there's 4 plants producing aggregate in the UK that actually is expanded by using carbon dioxide. The industry are using alternative fuels to lower the carbon footprint of concrete. So concrete already, the cement in the UK has reduced 25% since 1998. I said they're already on a downward trajectory. They're doing lots of things to try to get that down to zero by using carbon capture. There's lots of different research going on with regards to that, but also looking at alternative types of cements as well. And all of these alkali activated cementitious materials, geopolymers, are available now, typically for low risk applications, but they're available, so they can be used. And in the future, who knows what that cement's going to be? Is it going to be with graphene? Is it going to be cement made out of carrots? Is it going to be concrete cement that actually holds a charge, which means our buildings can act as a smart battery? I mean, who knows, with the processes and the innovation that's going on, the way that our built environments are going to be working with us and for us, and how we treat our buildings as not just places that we inhabit, but actually our resources for doing other things as well as resources for future building. Hugely important. So that I'm far too fast, and I should have just talked about one thing in an hour. So and 20 minutes. So these are my 4 things really. Use it to reduce energy, use less stuff, get the carbon footprint of that concrete way down. These are all things you can do right now and design for longevity. And those are all really, it's important that we keep designing and thinking, recognizing about the importance of sustainability. But we don't make any knee-jerk reactions, but we just look at the science, look at what's proven, keep an eye to the future and make the right decisions now for the buildings that we know are going to be appropriate for now and in the future. So anyway, thank you very much.